In this video, we're going to take up one more problem on projections of lines. A line capital AB 100 mm long is inclined to HP at 45 degrees and inclined to VP at 30 degrees. Draw the front and top views of a line and determine their lengths. Also, measure the perpendicular distance of NB from both HP and VP. So this is as he has given a true length of the line of 100 mm long, is inclined at 45 degrees to HP. Again, he has given the true inclination with respect to HP, and inclined to VP at 30 degrees. Again, the true inclination is given with respect to VP. Draw the top and front views of a line and determine their lengths. So we need to determine their lengths, that is the front view and top view lengths, and also measure the perpendicular distance from the NB from both HP and VP. Now here, so how to analyze this problem? So basically here he has given that whether the one end of the point A is in both HP and VP has not given that this, but still we have considered this as one end of a point is resting on both HP and VP. Why we have considered that? So that is basically because you can see here he says it is measure the perpendicular distance of the NB from both HP and VP. So what is the perpendicular distance? The NB distance, this is the perpendicular distance which is with respect to HP, and also this is with respect to VP. So we need to find out this distance. So if you want to find out this distance, so this is the minimum distance what you are going to get when the point end A is resting on both HP and VP. As I give the distance above HP and in front of VP, then what happens? The distance with respect to both HP and also VP will keep on increasing. So we need to find out the minimum distance. So I will get the minimum distance only when one end of the point A is resting on both HP and VP. So that is the reason why we have considered one end of the line is on both HP and VP. So he says a true length of the line of 100 mm long is inclined to HP at 45 degrees. So which is the true length of the line? So here this is the true length of the line which is 45 degrees to HP. Since it is the inclination with respect to HP can be seen in VP, when you look from the front view, we can see that this angle which is 45 degrees to HP. Similarly, he says the true length of the line is inclined to VP at 30 degrees. So this I can see only when I look from the top view, we can see that it is on HP. So here the true inclination with respect to VP can be seen in HP. So this is the true length of the line of 100 mm which is inclined at 30 degrees to VP. So this is how we will be able to get the initial position of the drawing. Once we get this, so naturally we are going to get the locus of B in the front view and also the locus of B in the top view. So once you draw a line inclined at 45 degrees to HP, so of a length of 100 mm, so this will going to be the B1 dash. So now we will going to get the locus of B in the front view. And when you draw a line at an inclination of 30 degrees with respect to VP and having a length of 100, so you're going to get the other end of the point B, which is again B2. So this will going to be the locus of B in the top view. Now once you get the locuses, it is very easy to find out the top view and front view. So to find out the front view, we have to take the top view. To find out the top view, we have to take the front view true length. So to do that, first we are going to find out the true length in the, first we are going to find out the top view now. To find out the top view, we need to consider the true length in the front view. So which is the true length in the front view? Which is A dash, B1 dash. As the condition says, when the line has to be in true length, it has to be parallel. So what does it mean? If I consider the true length in the front view, obviously that line should be parallel to VP. So that means it should be parallel to XY line in the top view. So to do that, if I consider this line A dash, B1 dash, if I look from the top view, it should be parallel to XY. When it will going to be parallel to XY, A is on VP. So obviously the image will be on HP. So B1 should also be on VP. Then only it will be parallel to VP. Then it can be seen in HP. So B1. So this is the reason why we can see AB1 is the line which is the top view of the true length line A dash, B1 dash. So here when we are rotating this, because we have the locus of B in the top view, with capital A as center, you're taking the radius of capital EB1. When you rotate, then what in space, what happens? The point B1 will going to move with respect to capital A. Till what? Till we will going to get the locus of B in the top view. So that means when you are rotating in space, what happens to the image? The image which will going to be in the top view, we can see that B1 is also rotating such that B1 will come and touches the locus of B. So that means that capital B1 will going to rotate till you will going to get the locus, it will going to hit the locus of B in the top view. So this point will going to be capital B in space. So as we rotate, so then the image will also be gets rotated from B1 to the locus of B here. Once you get this point B, then join A to B with a dark line. So that we will going to get the top view. So since it is the inclination with respect to VP, so you will going to get beta, apparent inclination. Similarly, now we need to consider the front view. To find out the front view, what we need to take is, we need to take the top view true length. Where is the top view true length? This is AB2. So we have the locus of B in the top view. So you have capital A and this is capital B2 because that is the true length line. So since it is the true length in HP, obviously the line has to be parallel to HP. So where you will going to get the line parallel to HP, we can see it in front view, that is in VP. So A dash is in VP, so B2 dash will also be on VP. So when you look from the front view, A dash is on VP, so obviously B2 should also be on VP only. So then only this line AB2 is parallel to HP or the true length in HP. So when you are with considering capital A and capital B2 with A as center taking the radius of AB2, when you rotate that B2, so that it will going to touches the locus of B in the front view. So when you look from the front view, since you are rotating in space, so what happens to the image? The image which will going to start rotating from A dash with small a dash as center, that B2 dash is slowly rising till where it will going to reach, till it will going to come and cuts the locus of B in the front view. So that you will going to get this B dash. When it is projected, you will going to get this point capital B. So join A dash B dash with a dark line and denote the angle as alpha. So this is how you will be able to find the front view length and also the top view length. So when you get this, so we need to find out, measure the perpendicular distance of the NB from both HP and VP. So the perpendicular distance with respect to VP, so that is this distance, which will be B dash. So that means we will going to get it as B2 dash. That is the one which will going to get. So B2 dash will going to be 50 mm, which is perpendicular to VP, and this B1 dash B1 will going to be the perpendicular distance with respect to HP. So B1 dash B1 will be 70.71. When you are doing it in computer, it will go, when you do it in manual, it will be 71 mm. So this is how you will be able to find the perpendicular distances of NB, both B and both with respect NB with respect to both HP and VP. So now we need to find out the top view length and front view length. Of course, I have not shown this here. We will going to do it when we are doing it in AutoCAD. So now this is how we will be able to analyze this problem. Suppose if I take it individually, now you can see here. Suppose if I want to take up, this is the front view, what we have shown. So we have taken the front view true length and we have taken the top view true length. So here we will going to get the locus of B in the top view and you will going to get the locus of B in the front view. With A dash as center, with A as center taking the radius of AB1, when you are rotating it here, so what happens? This will also rotate so that the image what you are getting here will going to cut the locus of B in the top view. So you are going to get the top view now. So here this is the front view point A dash B1 dash. So when you write the top view, it becomes AB1. So when you're rotating A dash B1 dash, so the image in the HP also will be get rotating so that B1 will going to come and touches the locus of B in the top view. So you're going to get AB. So here this is in space. When you are projected, you are going to get this point. So this will going to be capital AB. So that is what we have shown here. with A dash. So we have the true length in the front view. That obviously that should be parallel to VP in the top view. So that is AB1 is the line which is parallel to VP. So with A as center, taking the radius of AB1, you are rotating such that it will going to cut the locus of B. So you will going to get the top view here. So this is what I have shown for the top view to find. Now similarly, when I take up the front view, so you have to take the top view true length, which is the top view true length AB2. So with A as center, taking the radius of AB2 when you are rotating it. So that means you are rotating in space, that is capital A with center. B2 as the radius, you rotate it such that it will going to come and touches the locus of B in the front view, so that you will going to get B dash. Then join A dash B dash with a dark line. So this will going to be the angle alpha. So when it is in space, so you are going to get this as capital AB. So this is what I have shown here in the orthographic view with AB. So we have taken the top view true length. So since this is the top view true length, obviously that should be line parallel to HP. So A dash is in HP. So B2 dash is also in HP. So therefore A dash B2 dash is parallel to HP. But because due to the presence of the locus of B in the front view with A dash as center, taking the radius of A dash B2 dash, you are rotated such that it will going to cut the locus of B in the front view. Then join A dash B dash with a dark line. So this will going to be the front view line. So this is how we will be able to analyze step by step also. That is front view and top view. Now we will going to try to solve the problem. I will going to show how to do it in manual. So first we are going to draw XY line and mark XY and VP and HP. So consider any point on both HP and VP with A dashes and mark this point as A dash and A and capital A and capital A. Considering by using the protractor with A dash as center, then measure an angle of 45 degree and draw an inclined line. And similarly with A as center, taking the angle of measuring the angle of 30 degree with respect to the XY line, below XY line, and you draw an inclined line. Then by using the compass with A dash as center, taking the radius of 100, cut it on this 45 degree line. Similarly with same center, that is A as center, taking the radius of 100, cut an arc on this 30 degree line and draw the locuses here, and here also you draw the locus and name this point as B1 dash and capital B here and B2 and capital B here. Then join A dash B1 dash and A B2 with little bit thicker than XY line. Now we need to find out the front view and top view. To find out the front view, we find out the top view. First we have to take the front view true length. So when you are taking the front view true length, A dash B1 dash is the front view true length. That is the reason why we have shown this as capital A and this as capital B. But we know that once it has to be true length in the front view, obviously that line should be parallel to XY line in the top view. So A dash B1 dash is the front view. The top view point of this line AB, A dash B1 dash is AB1. A is on VP. So obviously B1 should also be on VP. Then only the line will be parallel to XY line. So therefore from B1 dash you draw a vertical projector such that it will going to touches the XY line. Therefore AB1 is parallel to XY in the top view. But due to the presence of locus of B in the top view here, with A as center, taking the radius of AB1, by using the compass, you draw an arc such that it will going to cut the locus of B in the top view, and you mark this point as B. Then join A to B with a dark line. Similarly, to find out the front view with A, then take the top view true length AB2. You take the AB2 since it is a true length in HP. So obviously the line is parallel to HP. A dash is on HP, so B2 dash should also be on HP. Then only the line will be parallel to HP. So you project that B2 point directly onto XY line because A dash is on XY line. See, to have the top view true length, the front view line of AB2 should be parallel to XY. What is the front view of AB2? Top view AB2, A dash and B2 dash. A dash is on XY line. Therefore, you project this point from B2 to the XY line, and then you mark this point as B2 dash. Then the locus of B in the front view is above XY line by this distance. So with A dash as center, taking the radius of A dash B2 dash, with draw an arc such that it will going to cut the locus of B in the front view here. Then you mark this point as B dash. Then join A dash B dash with a dark line. Then join B dash and B, both should lie on the same line. And then by using By using the scale, you measure the distance from B1 dash and B1, so that will be equal to 71 mm when you are doing it in manual. Similarly, measure the distance from B2 dash to B2, so it will going to be 50 mm by using the scale. Then mark these and then show the dimensions accordingly, and this is how you will be able to find, or you will be able to solve this problem and analyze and solve this problem manually. Thank you.